acid, you wouldn't find this phosphatidylcholine. You'd find a complex mix where the phosphate is derivatized with all kinds of things. Sometimes like an amino acid like serine is put on there, sometimes choline, sometimes another glycerol, or ethanolamine. And some of these are common enough that they have their own name, like this complex one down here is called cardiolipin. This one we were just looking at with the choline group attached is lecithin. You've probably heard of that. It's a component.
It's in eggs, right?
Yeah. Well, it's used. It's an emulsifying agent generally. It's used in lots of things. It doesn't just come from eggs, but you can find it there. So here are some of the chemical compounds that are stuck on the phosphate. So phosphatidic acid would just have hydrogen or nothing there. Phosphatidylcholine would have that stuck on the phosphate. Ethanolamine, serine, you can put sugar-like molecules on there, sugar alcohols. All kinds of things can end up being in the polar head group. But these very common ones, the lecithins, are just phosphatidylcholines. You can get them from all kinds of sources. And they're used to emulsify fats, like in chocolate manufacture and so on, because they have this empathic character, mixed polar, non-polar character. They're good at emulsifying really water-insoluble elements. So you often see lecithin added to foods. And it's just phosphatidylcholine. Okay, so that's one big membrane component, the glycerol-based phospholipids. Then there's another kind called sphingolipids, where instead of glycerol, everything is built on this molecule known as sphingosine. And this, so here's the sphingosine molecule. So glycerol was real simple. It just had 3 carbons, 3 alcohols. This sphingosine molecule is quite long, and it looks like it's got a fatty acid already on it, but it's actually not attached separately. This was never a free fatty acid. It's just a long hydrocarbon tail that happens to be part of this sphingosine molecule. You could put a fatty acid on there, and where it goes is on this amino group here. So this becomes another long hydrocarbon chain when you put a fatty acid on there, on the nitrogen, through an amide linkage. So this is the simplest kind of membrane sphingolipid you could have. It's called a ceramide. You'll notice that the names of these sphingolipids often have kind of vocabulary associations with brain tissue or nerve cells, nervous tissue. That's where a lot of these are found in high concentration. Sphingomyelin, you may have heard of myelin membranes. These are the membranes that wrap around nerve bundles. They have not just a bilayer membrane, but just wrapping one layer after another. And those membranes are very rich in the molecule sphingomyelin. It's where you take a ceramide, like we just saw in the last slide, and put a phosphorylcholine or phosphatidylethanolamine on the end. So just to review, this part here is this sphingosine group. Here we've attached a fatty acid to that nitrogen. So now it kind of looks like the glycerol-based ones. There's two long hydrocarbon tails, at least one of which is fatty acid going to the membrane. This becomes the polar head group, and here's a phosphatidylcholine attached to it. So that's the same kind of polar head group, this time attached to a different base. So this is choline sphingomyelin.